Hey guys, today I want to go over the earthquake notes. As always, you can follow along with me here on the side as we go over the guided notes portion and the PowerPoint that I went over in class right here. So an earthquake is the vibration of the earth produced by the rapid release of energy. Plug that in right here. Okay. Faults are fractures in earth where movement has occurred. So we call that a fault, and it will usually result in a fault line, which we'll talk about later. The epicenter is where the location on the surface directly above the focus, and the focus is the point on Earth where the earthquake starts. So the focus is generally where you have the release of energy, and we call the epicenter the point on the surface that's directly above the focus. You can plug those in here. Let me move this down. Okay, about 95% of all earthquakes occur at faults. I just thought I was here. You can also see that on the other side. Let me do a little bit of housekeeping here so you can see all of the notes at once. Okay, so now again, the cause of earthquakes here, you can see how the earthquake happens here along the fault. Here's the fault line. Moving on. You can also see it here, slippage along a fault line. You can see how these trees aren't quite lined up with one another. Okay, so most earthquakes are produced by the rapid release of elastic energy. Think a rubber band here, same type of energy that's stored in rock by the great buildup of pressure. And when the strength of a rock is exceeded, which means it's maxed out, it suddenly breaks and causes the vibrations of an earthquake. There's also movements that come after earthquakes that we call aftershocks, and they're kind of smaller earthquakes that happen after the larger initial one. Small earthquakes called foreshocks also happen before a major earthquake, and these can even happen days before a major one. It can be a good indicator that an earthquake is about to happen. Let's get into the type of waves here. Surface waves travel along Earth's outer layer, and the movement's kind of like waves on an ocean, and these are the slowest type of waves. We have P waves, or push and act as a compression type of wave, and push and expand the rocks in the direction that the wave is traveling. And these can travel through solid, liquids, and gases, and P waves are the fastest seismic waves, so these will get to an indication spot before any other type of wave. And S waves shake the particles at the right angle of travel and only travel through solids. Okay, so P waves are the fastest, S waves are the second fastest, and surface waves are the slowest. And we will talk more about P and S waves as we get through earthquakes. All right, a seismograph is an instrument that records earthquake waves. And seismograms are traces of amplified electronically recorded ground motion made by seismographs. Okay, we also use the Richter scale, and is used to measure the magnitude of an earthquake. It's based on the amplitude of the largest seismic wave recorded on a seismogram. Okay, and the amount of a shaking for a 5.0 earthquake is 10 times greater than the amount of a 4.0. So as you move up in numbers on the Richter scale, it's an increase by 10-fold. Okay, and the moment magnitude is derived from the amount of displacement that occurs along the fault zone. Think this as being the fault zone here. It does not measure the strength of the seismic wave. It only estimates the energy released by the earthquake. And here you can see a good indicator of different types of magnitudes here and what we can see and what we feel. Here are some notable earthquakes from around the world here. This is an outdated list, and there's obviously, outdated list, and there's obviously more that have happened since 2001, but this is a good indicator of some of the larger earthquakes that have happened in the past few years. Okay, so locating an earthquake here. Get to the right notes. The difference in the P and the S waves provides a way to locate the epicenter, and we'll do an activity in class where we try to locate P and S waves and determine where the earthquake started and how long it took to get there. Okay, the greater the interval measured on the seismogram between the S and the P wave, the greater the distance to the earthquake. Time travel graphs for 3 or more seismograms can be used to find the exact location of an earthquake epicenter. We call that triangulation, and your GPS on your phone actually uses the same type of technology for that. So not the satellites in space for GPS, but the same triangulation method. Again, we have about 95% of the major earthquakes that occur only in a few narrow zones, usually around here, all the way around here. And there's a map that I'll show you in class that has the same idea about that. So getting into seismic vibrations here, the damage to buildings and other structures from earthquake waves depends on several factors. Number 1 is the intensity. Number 2 is the duration of the vibrations. Number 3 is the nature of the material on which the structure is built. And number 4 is the design of the structure. And all 4 of those can go in right here. You can see some earthquake damage. Okay, we're going to talk about liquefaction here. So where loosely consolidated segments are saturated with water, earthquakes can cause a process known liquefaction that causes things to kind of sink down into the ground. You can see that here. All right, a tsunami is triggered by an earthquake that occurs where a slab of the ocean floor is displaced vertically along a fault. So a tsunami can occur when the vibration of the earthquake sets an underwater landslide into motion. Okay, think more of a tsunami as an underground earthquake. A lot of people see a tsunami as that giant tidal wave that reaches land, but the tsunami is actually the underground earthquake. What results after that is usually a tidal wave, and those are two separate things. So tsunamis give you little warning before they strike and cannot usually be seen in the open ocean because of the traveling wave. You can see the movement of the tsunami here as it intensifies as it reaches land and the tidal wave that occurs. So tsunami warning system, large earthquakes are reported to Hawaii from Pacific seismic stations, and although tsunamis travel quickly, there is sufficient enough time to evacuate all the areas but as close to the epicenter. And while we do have these in place, tsunamis generally do cause significant damage. So other damages or other dangers that earthquakes can trigger, landslides and fires. Think of the 1906 San Francisco fire here, triggered by an earthquake. And how do we predict earthquakes? Okay, we have short-range predictions, and so far methods for short-range predictions of earthquakes have not generally been very successful. And we have long-range forecasts. So scientists don't understand enough about how and where earthquakes will occur to make long, accurate predictions. We do have those seismograms in place, and those serve as a general early warning system, but it's still random and it's hard to predict. So a seismic gap is an area along a fault where there has not been any earthquake activity for a long time, and it kind of makes everybody think that, hey, this might happen soon. Okay, and that's all for these notes. Thank you.